So hey guys, welcome back to my channel. So in this video we are going to see the problem on diagonal sum. In this we have to take the sum of primary diagonal and secondary diagonal and we will get our output. Basically this is the row of our matrix and this is the column of our matrix. Then the diagonals will be this. This is the called the diagonals. There are two diagonals here. One diagonal is this and another diagonal is this. So I have created a dummy matrix. So this is the row of our matrix and this is the column of our matrix, as you know. Then diagonal of our matrix means this is called as the diagonal and this part is also called as the diagonal. So this first diagonal is called as primary diagonal and second diagonal is called as secondary diagonal. So we have to add the primary diagonals and secondary diagonals, then we will get our output. So let's see what will be the sum of our primary diagonal. So 1 plus 6 plus 11 and plus 16. So its sum will be 34. Then secondary diagonal sum. So it starts from here. 4 plus 7 plus 10 plus 13. So its sum will be 34. So our answer will be, so we have to add this primary sum and secondary sum. So it will be 68. So our output should be equal to 68. So this way we have to calculate our diagonal sum. And one important note here is diagonal sum is only possible when our n is equal to m. Here only this case we can apply diagonal sum. Okay. Here the matrix is of 4 by 4. So m is equal to n. So we can find this diagonal sum. So it can be 3 is into 3 or 5 into 5 or 6 into 6 means m is equal to n. It should be only we can apply this method. So we have taken the example for even number. So for odd number, if the matrix is odd, created a matrix here of 3 by 3, it is an odd matrix. For that we have to add these numbers. Okay, this and this. So we have to add the two diagonals of the matrix and we will get our sum. So in this the 5 number is repeated in primary diagonal also and in secondary diagonal also. So let's see the sum of the primary diagonal here. 1 plus 5 plus 9, so it will be 15. And secondary diagonal sum will be 3 plus 5 plus 7, so it also 15. So our answer will be 30. But here our 5 number is repeated in both, in primary diagonals also and in secondary diagonal also. So we have to the 5 ones only. So we have to take primary diagonal plus secondary diagonal to remove the primary diagonal sum here. So we will get our correct output, that will be 25. So here I have created the matrix again. So we have to calculate the primary diagonal sum and secondary diagonal sum, and we have to add that both the sums and we will get our output. So you can observe in the primary diagonal here the index are same. Okay, so here 0 and 0, and here 1 comma 1 means 2 comma 2, and here 3 comma 3 means our ith index is equal to j index. For secondary diagonal, the elements are on, let's take here 0 3, then 1 comma 2, then 2 comma 1, and here 3 comma 0. For secondary diagonal, our I plus j is equal to array of length minus 1. So you can see here 0 plus 3, the sum will be 3, 1 plus 2, the sum will be 3, then 2 plus 1, the sum will be 3, plus 0, the sum will be 3, and it is equal to our array of length. So let's see the pseudocode. So we have to take a variable here sum, and it will initialize with 0, and we have to run here nested for loops for int I is equal to 0 to n, and also for int j is equal to 0 to n. Then we have to give the condition. If our I is equal to j means it is the primary condition, then add that element in the sum, and else we can give the condition as if our summation of I plus j equal to array of length minus 1. So in that case also we have to add the element in the sum variable. So this condition is for secondary diagonal and this condition is for primary diagonal. So let's start with our demonstration. I have created a class called demo, and in that I have created a main method. Now in this we will create an array here. Created a 2D array here. Now let's create a function. Public static return type will be in, and here we will take the name as diagonal sum, and we will pass our array. Now let's take a variable sum and initialize it with 0, and we will run here nested for loop for int I is equal to 0, I should less than array of length, and I will get updated. And here we will to run another follow for int equal to 0. J should less than array of 0 dot length will gets updated. Now this is for row and this loop is for column. Now we have to give here condition. If our I is equal to j, then add that element in the sum variable. So array of I and j. So this condition is for primary diagonal. And else if our sum of I and j equal to our array of length minus 1, that means 3, then we have to add all the elements in the sum variable. Array of I and j. And this condition is for secondary diagonal. Created a variable sum and I have passed here 0, and here we have run a nested for loop, and simply we have given condition if I is equal to j, then add the elements in the sum variable, and else if summation of I plus j equal to array of length, then also add that sum is equal to the sum. Now let's return the sum, okay, to the main method. Completely created a function for diagonal sum. Now let's call the function from the main method. So here we will pass our diagonal sum. So we have called this function from the main method. Now let's run the code and see the output. So the output that we have get is 68. So thank you for watching this video.